So last time we had taken a look at 2.3 and we were very pleased that we now have a simpler way to do some of this, right? Absolutely. And we had encountered these basic derivative rules or properties, and they were all exactly what we kind of hoped they would all be. They just all followed these wonderful patterns, and they're very simple and direct. They're what we would expect. And so we have one more example to take a look at, and that example is number 5. All right, so on taking a look at this one, we want to find an equation of a tangent line. I know I haven't handed back the homework yet, but when I do, some of you are being a little bit careless in looking at the directions on problems. Be really careful. Don't stop short of what you're asked to find. Like on this one right here, if we compare this to the previous problems, you might be tempted to sort of just find this derivative using these rules and think you're finished. However, this problem actually asks you to find the tangent line, which means you need to evaluate the derivative at a specific point and then use that to create an equation of a line. Are you guys with me? So be really careful, mark things up, make sure that you're clearly answering the question that's asked on the particular problems you're working on. All right, this, however, does tell us that we need something about the tangent line. Whenever you see that word tangent line, or those words tangent line, you should be thinking that I need to do a derivative. Because derivatives are equivalent to finding slopes of tangent lines. Okay? Now this one's actually given it to us in a very nice fashion because it actually looks like the power rule. I've got functions with powers, so that's actually a very friendly format for this to be given in. What is the derivative of 2x to the 3 halves? How do we find that? You bring the 3 halves down and you multiply, right? So you're going to take the 2 at the beginning times the 3 halves, which is 3. So that's going to give you 3. And then what are you going to do with that new with that exponent now? You're going to subtract 1. So what is 3 halves minus 1? That's 1 half. Okay, so we're going to do that same process again with negative 3x to the negative 1 half. So we're going to take that negative 3 and we're going to multiply it by negative 1 half, which is going to give us a positive, right, Blaine?
Yes.
Positive what?
3 over 2.
3 over 2, perfect. What's the new exponent going to be?
X to the negative 3 halves.
Perfect. So we actually have to remember that we're dealing with negatives here, so when we have that negative 1 half minus 1, it's going to give us negative 3 halves. And we're done. Now, we really don't have anything that says that we have to simplify this or clean it up, but it might be helpful as you're taking a look at this, especially if you don't have a calculator handy or whatever with you, to think about this in terms of square roots, because that's what powers of 1 half are, right? So it might be worth it to you to take a look at thinking about this as 3 square root of 2, I'm sorry, not 2, square root of x, plus, and then this 3 over 2, and then this x to the 3 halves is in the denominator now, so we have x to the 3 halves. 3 halves is the same as 1 1/2, right? So that means you've got x to the 1 power and x to the 1 half power, which is just the square root of x. Because that's a 1 and 1 half power. This form is easier for us to evaluate from and plugging in the number 4. So I have 3 square roots of 4 plus 3 over 2 times 4 square roots of 4. So what is 3 square roots of 4? How much is that? That's 6. Good. You know what? Let me do it over here. I've got 3 in the numerator, and then what is 2 times 4 times the square root of 4? That is 16. So I have 6 plus 3 over 16. While I could write that as 6 and 3 over 16, like a mixed number, remember our purpose in doing this is actually to find a slope. And slopes, as well as many other features in mathematics, we use improper fractions to see them more clearly. They work a little bit more conveniently to manipulate with. So if I change this to a mixed number, from the mixed number, into an improper fraction, what do I get? It is 99 over 16. And if you're looking at me confused a little bit, what I'm suggesting we do is to simply write 6 as something over 16. So we can multiply 6 times 16, and we can add it to the 3. Okay, so we can combine those fractions. So this is our slope. That's what we just found. We're not done. But we have found the slope of the line. I need to have a line at x equal 4. So I've got the x value. I've got the slope value. I need one more thing. What do I need? I need the y value. So here's what the formula is that I'm thinking of at the moment. So I know x1 and I know m. I need to know y1. How do I find y1?
Just plug in 4 to the
Right. I take the original equation. It's my function, right? And I evaluate it at x equal 4. So I'm going to do it up here on the very top of my screen so that I'm not running into the text at the bottom. I need to find f of 4, which means I want to find 2. And then I've got x through to the 3/2, which is a 1.5. So you know what, let me just do it this way this time. I'll just put the 4 in here. I'll let you this time use your calculators to find a value. Why not? Minus 3 times 4 to the -1/2, right? See if your calculators will spit something back out for you. Put it back into an improper fraction form, okay? And if you're not sure how to do that on your calculators when we get broken up for group works and such, let me know and I'll show you how you can do that if you don't know where that feature is in your calculator. Does it give you a value? I don't think it's a whole number, is it? What is it? 29 over 2. I've got a couple people suggesting that that's the case. Does that look okay? Does everybody have 29 over 2? So this is the y1 value in what I'm looking at, right? This is y1. So down here along the bottom, now I have y minus 29/2 equals m, which is the 99/16 times x minus the x value, which is 4. I'm going to go ahead and work through simplifying this as to y equals, that's sort of what mx plus b form. Your book does not indicate that you have to do that, so if you were to leave it like this, the way they ask the question, I would count it correct. I will tell you that when I ask the question on the test, I'm going to tell you that I'd like for you to represent it in the standard slope-intercept form. So I'm going to want to see that you can do the algebra to simplify this. And it's good practice just to remember how to work with fractions a little bit on this because we don't encounter them on every problem, but when we do, sometimes people get a little bit antsy because they feel a little bit out of place. So let's just go through it real quick. I have y minus the 29/2. This is 99 over 16x. And then I'm going to take that 99 over 16 times the -4, so this is negative. And it'd be 99 over 4 because the 4 here is going to reduce with the 16, right? After that, I can actually add this